Hi, Assalamualaikum and good day. Today we are going to learn about chapter 4 that is on integration. Following are the objective of today's lesson. Hopefully, by the end of this session, you should be able to define the basic concepts of integration, understand the basic rules of integration, and apply integration by substitution. Integration is a process to find the antiderivative of a function. The process of integration reverses the process of differentiation. The integration symbol refers to a stylish S. After the symbol, we put the function that we want to find the integral, which is known as integrand, and then end it with the x, in which x here is the variable of the integration. For indefinite integral, the final answer is always plus with c, which refers to the constant of integration. Practically, if the derivative of capital Fx with respect to x is equal to small fx, then integrate the small fx with respect to x. The answer is equal to capital Fx plus c. Graphically, the derivative of a function is illustrated by the slope of the curve defined by the function. Meanwhile, the integral of a function is represented by the area under the curve within the interval. Following are some basic rules that we can apply when integrating functions. We have constant rule, multiple constant rule, sum or difference rule, power rules, logarithmic rules, exponential rules, and trigonometric rules. Refer to example 1. Evaluate the following indefinite integrals. Integrating square root 5 dx, the answer is square root 5x plus c. This is by using the constant rule. By using power rule, integrate x to the power of 1 over 4, the answer is equal to x to the power of 1 over 4 plus 1, which is 5 over 4, over 5 over 4 plus c, which can be simplified to 4 over 5x to the power of 5 over 4 plus c. To integrate negative 2 over x to the power of 3, move x to the power of 3 up first, then apply the power rule. You will obtain negative 2x to the power of negative 2 over negative 2 plus c, which can be simplified to 1 over x squared plus c. As for d, to integrate, you also need to use the power rule. You will get 5 minus 4x to the power of 5 over 2 over 5 over 2 multiply with negative 4, then plus with c, which can be simplified to 5 minus 4x to the power of 5 over 2 over negative 10 plus c. Take note that negative 4 here is referred to the derivative of 5 minus 4x. Proceed with example 2. Evaluate the following indefinite integrals. To integrate a and b, by applying the power rule, you should be able to get the following answer. As for c and d, simplify the given expression first. Then apply the power rules. You should be able to get the following answers. Refer to example 3. Evaluate the following indefinite integrals. For a, integrate 5x. The answer is 5x squared over 2. and integrate 4 sin x, the answer is negative 4 cos x, then plus with c. For b, 1 over secant x can be written as cos x. Thus, integrate 4 cos x, the answer is 4 sin x. Integrate negative secant tangent x, the answer is negative secant x, then plus c. As for c, integrate secant square x, the answer is tangent x, and integrate secant tangent, the answer is secant x, then plus c. Refer to example 4. Evaluate the following indefinite integrals. For a, integrate cos x, the answer is sin x. Integrate 2 over x, the answer is 2 ln x. And integrate negative 3, the answer is negative 3x, then plus c. For b, simplify the expression first before you integrate. Integrate x, the answer is x squared plus 2. Integrate 2, the answer is 2x. And integrate negative 5 over x, the answer is negative 5 ln x. Then plus c. For c, expand x minus 5 to the power of 2 first. You will get x squared minus 10x plus 25. Divide this expression by x to the power of 2 and simplify. You will get 1 minus 10 over x plus 25 over x squared. Integrate 1 is x. Integrate negative 10 over x is negative 10 ln x, and integrate 25x to the power of negative 2 is negative 25 over x, then plus c. Proceed with example 5. Evaluate the following indefinite integrals. For a, integrate exponent x is exponent x, and integrate negative 2x is negative x squared, then plus c. For b, integrate cos x is sin x. Integrate 4 over 5 exponent x is 4 over 5 exponent x, and integrate negative 6 is negative 6x, and plus c. As for c, integrate 1 is x, and integrate negative 2 to the power of x is negative 2 to the power of x over ln 2, then plus c. Some integrals may not be able to integrate directly from the basic integration rules. One method that can be very useful is known as integration by substitution, which is basically reverse the chain rule. The idea behind the integration by substitution is to replace a complicated integral originally in x term to a simpler integral which is in term of u. It is done by substituting part of the integrand with the variable u and part of the integrand derivative with du. The main challenge in applying the integration by substitution is to think of an appropriate substitution. The key is to find the outside function and the inside function, where the outside function is the derivative of the inside function. Then, use a suitable substitution that will simplify the original integrand and make the integral much easier to solve. Following are the steps for integration by substitution. 1. Choose u so that du become a factor of the integrand. 2. Express the integrand entirely in terms of u and du by eliminating the original variable. 3. Evaluate the new integral. And finally, express the final answer in terms of the original variable. Refer to example 6. Solve the following integrals. As both integrals cannot be solved directly using basic rules of integration, you need to apply integration by substitution. For a, by letting u equal to x squared plus 1, differentiate, you will get du over dx equal to 2x. Substitute this into the original integral and simplify, you will obtain a new integral. For b, by letting u equal to x to the power of 3 minus 1 and differentiate, you will get du over dx equal to 3x squared. Substitute this into the original integral and simplify, you will get 1 over 3 u to the power of negative 1 over 2. Integrate with respect to u and replace the u back to x to the power of 3 minus 1, you should be able to get the following answer. Now proceed with example 7. Solve the following integrals. For a, by letting u equal to 1 minus x and differentiate, you will get du over dx equal to negative 1. Substitute this into the original integral and simplify, you still get x inside. As u is equal to 1 minus x, x can be written as 1 minus u. Replace into the x and simplify, you will obtain a new integral in terms of u only. Integrate with respect to u and replace the u back to 1 minus x, you should be able to get the following answers. As for b, by letting u equal to square root x, which can also be written as x to the power of 1 over 2, differentiate, you will get du over dx equal to 1 over 2 square root x. Substitute this into the original integral and simplify, you will obtain 2 cos u. Integrate with respect to u and replace the u back to square root x, you will get 2 sin square root x plus c as the final answer. Refer to the last example. Solve the following integrals. For a, by letting u equal to cos x and differentiate, you will get du over dx equal to negative sin x. Substitute this into the original integral and simplify, you will obtain negative exponent u. Integrate with respect to u, you will get negative exponent u plus c. Replace the u back to cos x, you will get negative exponent cos x plus c as the final answer. As for b, by letting u equal to 4 minus 3x and differentiate, you will get du over dx equal to negative 3. Substitute into the original integral and simplify, you will obtain negative 1 over 3, 1 over u. Integrate with respect to u, you will get negative 1 over 3 ln u plus c. Replace the u back to 4 minus 3x, you will get negative 1 over 3 ln of 4 minus 3x plus c as the final answer. In order to check your understanding on basic integration, please do the following exercise. In the next lesson, you are going to learn on how to solve the definite integrals, so stay tuned. Till we meet again, stay safe and stay blessed. Assalamualaikum.